Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. I am Ni Ashraf Farhanuddin bin Abdul Rahman. Today I would like to present about our project focusing in literature review. A literature review is a compilation of previous research on a given topic. It gives you a broad overview of current knowledge, allowing you to go deeper into specific ideas, methods and research gaps. The content of this literature review in this project are theory of normal stress and normal strain first, second, thin cylinder, and third, torsion. The process and theory of our straw tower prototype. During prototyping, we as designers will definitely have logistical concerns about the shape of the prototype to be built, the nature of our prototype in terms of materials, whether our prototype can withstand test loads weighing less than 8 kg, and identifying the appropriate shape to match the features which we want to match the durability that will be used on our prototype. For the design we designed, it turned out that while testing the prototype by placing a load of 8 kg, it was not able to withstand the load of that weight. Our prototype beam bent and broke after about 5 seconds when the load was placed. So our expectation of the weight of the load that our straw tower can bear exceeds the expected storage condition. Our straw tower is built with 7 pulls and 8 beams. The content of this literature review in solid mechanics. Normal stress. When a force is applied to a cross-section region, it is called stress. The strength of the force approaching normal to area is known as normal stress, sigma. Tensile stress occurs when a normal force or stress pulls, whereas compressive stress occurs when the force of stress push. The stress tau is the intensity of force acting tangent to area. Figure shows type of force acting on a cross-section area, where figures show the type of force acting on a cross-section area. The formula for normal stress can be expressed as average normal stress over internal resultant normal force. The formula for normal stress can be expressed as average normal stress equal internal resultant normal force over cross-section area of the bar. Next, normal strain. Strain is described as the deformation of a solid owing to stress, while deformation is defined as when a force is applied to a body, the body shapes and size tend to change. Normal strain epsilon is elongation or contraction of a line segment. Shear strain is the change in angle that occurs when two line segments that are originally perpendicular to one another. This angle is denoted by gamma, and it's always measured in radians. Since strain is a ratio of lengths, it is dimensionless. Strength is always positive. Strength is always positive for an increase in dimension and negative for a reduction in dimension. We can show the figure how it's look, and then the formula for normal strain can be expressed as strain Strength dimensionless equal change of length over initial length equal average normal stress over Young modulus.
Hello, my name is Fakri Shami bin Sharil. My number is AN200023. Today, I will tell you about the methodology of my experiment. Okay, next, the development stage of design. First, emphasize. Second, define. Third, ideas. Fourth, prototype. Next, we go to the test, and finally, the result. The first stage is emphasize. It is a process to gain an emphatic understanding about the problem that we are trying to solve it. So, we meet a Google Meet to discuss about it, to pick a right materials and do a right designs. Second, define. During this define stage, we try to define the problem as a statement problem of the project that we are doing. This stage will assist designer in gathering great idea to create features, function and other elements that allow us to solve the problems. For the third stage is ideas. Now we are ready to start generating all the ideas that we are collecting from the beginning. With this solid background, we can begin to think outside the box to identify new solution to the problem statement we have created. For the fourth stage is prototype. At the prototype stage, our group has made a prototype according to the final decision that we have made with our discussion and all of our problem statement. Prototypes are made carefully to follow the measurement that have been decided in the previous discussion. For the fifth stage is testing. So, we will test our prototype with load. At this stage, we will know that the design we make through the prototype has the resistance to withstand a lot of load or not withstand the load that has been placed. For this testing, we use 1 kg until 8 kg loads. Finally, the last stage is result. This is the last stage. The result will be made from the tests that have been done. The result will be recorded and reported. Next, the materials that we needed to build the prototype that we have discussed. First, ruler. Second, scissors. Third, knife. Fourth, tape. Fifth, straw. And lastly, hot glue gun. For all the materials that we used to make the prototype is cost only 5 ringgit.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Hakimin bin Zainuddin. My matrix number is AN200111. Okay, I'm from group 9 and I want to tell about my result, my group result from my experiment. So the straw tower have been made by my group. So you look at the photo, very beautiful and very strong. Okay, now we want to look at the result, what we have done. For the result, we have test at 5 type of load, at 2 kg, 4 kg, 5 kg, 7 kg, 8 kg. So for the first picture, we have looked at the picture. 2 kg of load stand at the straw tower. Nothing happened and the straw tower still stand properly, strongly. Okay, at the picture of picture number 2, 4 kg of load above the straw tower, nothing happened also, and it can stand properly again. Okay, and the third picture, 5 kg of load, nothing happened also, and the straw tower still stand properly. Okay, and fourth, 7 kg of load, it also nothing happen, and the straw tower stand properly. And five, very sad, the straw tower collapse and fall down after we put we put the 8 kg of load. That's all from me. Thank you.
Okay, for calculation part, if we look at the table, we can see the perimeter and measurement of our tower, where the length of our tower is 0.23, height is 0.25, width is 0.25, straw thickness is 0.007 meter, outer radius is 0.6 meter, and inner radius is 0.005 meter. Okay, after that we want to calculate the normal stress for our tower. Okay, normal stress, the strength of force per unit area acting normal to area is known as normal stress. The equation is used to calculate the theoretical normal stress acting on every straw is average normal stress equal P, internal resultant normal force, over A, cross sectional area of the straw. Okay, so first we have to find the area of the straw. We substitute the value. We got the area of the straw is 3.46 times 10 exponent power of negative 6 meter square. So after that we find the value of P, where P is the force acting on the tower. 23 is height of the tower times 9.81 is gravity value. So we got the value of P is 225.63 Newton. Then we substitute those value into equations. Okay, we substitute 225.63 over 3.46 times 10 power exponent negative 6. So we got the value for normal stress is 65.21 megapascal. Next in normal strain. Normal strain, our tower is made from straw. As we know, straw is made from polypropylene. Polypropylene is a thermoplastic polymer. It's used to make the most common type of drinking straw. This plastic is well known for its strength, lightness, and inexpensive cost for manufacture. Young modulus for polypropylene is 1325 megapascal. When 8 kg load is put on the top of tower, the stress is assumed to be evenly distributed to each support straw. The normal strain can be calculated by using normal stress over Young modulus polypropylene. Okay, so we substitute the value of normal stress 65.21 over the value of Young modulus 1325. So we got the value for normal strength is 0.049. Okay, for thin cylinder, the top of the tower function as a compressive force on the 8 kg load when it is placed on it. So we can calculate the hoop stress and longitudinal stress operating on the top of the tower due to the straw under 8 kg load. So the 8 kg load is supposed to be distributed evenly among the 28 straws that make up the top of the tower. The hoop stress can be calculated by using this equation. P equal 8. 8 is the amount of the load times 9.81 gravity over 28. 28 is a value of straw. We got the value of P is 2.8. Okay. When P is the force acting on the top of the tower, T is the thickness of the straw, R is the inner radius of the straw. So for hoop stress, we substitute the value hoop stress equal PR over T, where P value is 2.8 times R value is the inner radius of the straw is 0.005 over the thickness of the straw 0.0007. So we got the hoop stress value is 20 kilopascal. After that we calculate the longitudinal. After that we calculate the longitudinal stress. Okay. The formula is longitudinal stress equal PR over 2T. So we substitute the value of P is 2.8 times R, inner radius of straw 0.005 over 2 times the thickness value of straw 0.0007. So we got the value the longitudinal stress equal 10 Pascal. The column formula is P CR equal pi square EI over KL square, where E is the Young modulus of the straw, I is the moment of inertia, K is the constant for the type of support, K is 0.5 because fixed at both ends, and L is the length of the support. Okay, moment of inertia, we substitute the value pi to calculate the moment of inertia, pi over 4 R for 0 minus R for I. So we got the value of moment of inertia 5.27 times 10 power or exponent negative 10, and then we substitute the value in the formula column, and we got the value for column 22.05 Pascal. Okay, that's all. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Mirza Zameh and my matrix number AN20067. Okay, for today, I will present two parts of my slides, or two parts of the report that I'm going to present is the conclusion. Okay, for the conclusion, our group has, first and foremost, our group has discussed a lot about it, and this shape, it has a suitable and strong well-stable strong tower. Thus, it has a wider range of base. The wider the range of the base, the heavier the load that it can withstand. The second of all, our group has successfully applied all the calculation and theory that we have learned in our class, such as stress and strain, or bending deformation calculation. For the third part, our group had through our project, we have do some of the mistake, and we already had improved it. And in the near future, if we are going to work to build a tower, we learn from this mistake, and we can apply it in our real life. For the last part, the recommendation. This recommendation is to improve some of our mistakes that we maybe forgot to take note, such as joint material. Using more stable joints such as plastic sinclair, it is more strong and concrete material as the connector of the straw. It has more stickier, so it can stick with the straw more strongly, and it can withhold more weight. And last but not least, the improvement that we are gonna talk about is we use a better plastic straw. We use a better plastic straw because our plastic straw is too cheap and it is easy to deform. But if the improvement that our suggestion is to buy expensive plastic straw, because it has more good quality than a cheap one, because it's not easily to bend and it is guaranteed. It has a strong plastic. Okay, that's all from our group. Thank you.